Hey everybody, David the AI Guide here. Welcome to another episode. Thanks so much for tuning in. I really appreciate it. A cure for cancer? We'll get to that in a second, but before we do, click the link below. Get your free AI resource. The resource is free, everything in the resource is free, and you'll learn more about AI than we can do in these short segments. Also, if you do get the resource, you'll be given the opportunity to participate for free in my beta course, The AI Safe Career Pivot. What does that mean? That means change to a career that is AI safe, and we help you with that. So check that out, and also get my book on Amazon, The Beginner's Guide to AI, History of AI, and Current Impact on 10 Industries. It's short, takes about 2 hours to read the whole book, and it really tells you where things are at with AI. So thanks so much for tuning in, and let's get back to that question about cancer. So about a year ago, and by the way, this is going to be a two-part series because it's so important, but about a year ago, we did a segment on a breakthrough in AI that could model proteins. And this was a major breakthrough. An AI had been created called Rosetta that could determine the shape of proteins. So what are proteins? Proteins are in your body and they run all of your body's processes. So everything that happens in your body is driven by a protein, whether it's good, like your digestion and fighting off viruses and stuff like that, or bad, protein gone awry can trigger cancer. So that was a huge breakthrough 2 years ago when they came up with Rosetta that allowed them for the very first time to model what these proteins look like. Because this is difficult stuff. We're talking about things that are at nanoscale, meaning less than a nanometer, and less than a micron. So there's been a subsequent breakthrough by the same people who did the Rosetta breakthrough. And they give a good description of this. Designing a protein is a bit like making a cabinet. The first step is building a backbone that holds the protein together. But then comes the hard part, figuring out where to install hinges on that backbone. Basically, they say, the hot spot for attaching all of the accessories that are going to make the cabinet work properly. And proteins function very much like this. Proteins have hotspots called functional sites that are the docks where medication can dock, or viruses or antibodies can dock to the proteins in your body. These sites are central to performing most of our basic biological functions. They're also a massive gold mine for designing new treatments and medical drugs. The problem is functional sites are very hard to map because of their tiny size. So the way that they've done this traditionally is they would mutate one spot on each protein and see what happened. And there could be hundreds or thousands of spots on a single protein. So this was a very labor-intensive and time-consuming process. This new study published in Science changes the game, led by Dr. David Baker at the University of Washington. A team tapped into an AI's, they say, imagination to dream up a myriad of functional sites from scratch. So basically, this is creativity by a machine mind. How did they do this? Well, they did it using deep learning. As a reality check, the team used the new software to generate drugs that battle cancer and design vaccines against common, if sometimes deadly, viruses. In one case, the digital mind came up with a solution that, when tested in isolated cells, was a perfect match for an existing antibody against a common virus. In other words, the algorithm perfectly modeled one of the body's own processes. So what are these protein hotspots? As I said, Baker's team had come up with TR Rosetta. This was the new one about a year ago. And TR Rosetta was an AI architect that generalizes how strings of amino acids arrange into structures at nanoscale. This is very, very similar to GPT-3 because DALL-E 2, that I did a recent video on, DALL-E 2. Because what DALL-E 2 does is you type in a short text phrase and DALL-E 2 creates art that goes with that phrase of text. Well, what this new AI does, the deep learning AI that Professor Baker and his team created, is it can create a protein structure and the hotspots from a string of amino acids. So this is a major, major breakthrough. And we're going to talk more about what this means, but it does open the door, not now, but down the road, to curing intractable disease. And we're going to talk exactly about how what Dr. Baker and his team have done does it in the next video, so be sure to tune in for that. In the meantime, click the link below to get your AI resource and/or get my book on Amazon, The Beginner's Guide to AI, and stay tuned for part 2 of this true breakthrough in immunology and treatment. Thanks so much for tuning in. We'll see you next time. Take care. Bye.